All right, so happy Thursday. I lied, happy Friday. So today's lesson is on midpoint and distance. So we're going to use the midpoint formula and the distance formula. And we're talking about the midpoint and the distance in a coordinate plane, meaning we are going to use ordered pairs. So I'm going to talk to you about the midpoint formula first. So the midpoint formula, and I kind of write it like this, capital M. The midpoint formula is the x1 plus the x2 divided by 2 and the y1 plus the y2 divided by 2. Now, before you think that's crazy, I want to explain what that means. When we find the midpoint of a segment, so I'm just going to kind of sketch a line segment over here and give you an idea. The midpoint is halfway in between, which really is adding up two things and finding the average, which is halfway in between. So we're just really, this is a fancy way of finding the average of two numbers, okay? It looks weird because we have to take the two x coordinates, add them together, and then find the average of those, and then the two y coordinates and find the average. But it's not difficult. So let's find the midpoint of 4, -7, and -2, 3. So 4 plus -2 over 2. That's my x1, x2. And then y1, -7 plus 3 over 2. All righty. So the midpoint is, well, let's see, 4 plus a -2 is just 2 over 2. And -7 plus 3 is -4 over 2. But this can be reduced. Well, let's see. 2 over 2 is 1, and -4 over 2 is -2. Okay? Let's do another example. A diameter of a circle. So I'm going to draw a circle for us, and I'm going to tell you that the diameter has endpoints. I'm just going to mark them like I see them. 5, -11, and -7, 6. May not look like it, but we know that that's what a diameter is. Remember that a diameter goes all the way across a circle. We're trying to figure out the coordinates of the center. Well, the center of the circle, that's this little guy right here, is also the middle, right? So we're just finding the midpoint again. So when we want to find the midpoint, we take the x coordinates and add them together and divide by 2. And then we take the y coordinates and add them together and divide by 2. So -7 plus 5 is -2 over 2. And 6 plus -11 is -5 over 2. And I can reduce that or simplify that one more time. -2 over 2 is -1, and then -5 halves. Okay? All right, we're going to try it again. If you wanted to write your -5 halves as -2.5, because I know some of you guys do that on a calculator, that is fine too, okay? We're just talking about ordered pairs. All right, so now we're going to find the midpoint. Maybe you want to pause your video. This would be a good time for you to pause the video and you try and then come back and check your answers, okay? So hopefully you paused. So the midpoint between 12.7 and negative 2.11 is 5, 9, the ordered pair 5, 9. And the midpoint between the coordinates 8, negative 3 and 10, 9 is the coordinate 1, 3. All right. Midpoint AB is the point, so the midpoint M is the ordered pair 4, 3. So 1, 2, 3, 4, 1, 2, 3. This is my midpoint. Coordinate A is the ordered pair 17, negative 5. You can't even graph that on here. That's all right. I'm going to plot it right here. This is coordinate A. I need to find out what coordinate B is. So if I were to extend this line, B is going to be somewhere over here. Okay. Well, I want to talk to you about what we know. We have been setting up that the midpoint equals x1 plus x2 over 2 and y1 plus y2 over 2. Well, I know what the midpoint is. I know that 4 goes to the x coordinate, x1 plus x2 over 2. And I know that 3 is the solution to the y coordinate. Okay. Here's what I also know. I know one of the points. So I know that 4 equals 17, which is the x coordinate, plus x2 over 2. And 3 equals negative 5 plus y2 over 2. All right. So this really is just an equation that we need to solve. I'm going to multiply, right? Or multiply both sides by 2 over 1 if that helps you think about it that way. So 8 equals 17 plus x2. And when I multiply both sides by 2 here, I get 6 equals negative 5 plus y2. To find the x ordered pair, B, right? I'm trying to find the points B, which is my x2 and my y2. I'm trying to find the coordinates for that. So I'm going to subtract 17 from both sides. Negative 9 equals x2. I'm going to add 5 to both sides. 11 equals y2. So B is the ordered pair, negative 9, 11. All right, so we're going to do that again. So I know x1 and y1. That's going to be point A. And I know the midpoint. So 4, the x coordinate, equals negative 2 x1 plus, I'm trying to find b, which is x2 over 2. The y coordinate of the midpoint, 1, equals y1, which is 3, plus y2 over 2. The undo of divide by 2 is to multiply by 2. So 2 equals 3 plus y sub 2, minus 3 from both sides. Negative 1 equals y sub 2. Again, the undo of divide by 2 is to multiply by 2. 2 times 4 is 8 equals negative 2 plus x sub 2. Add 2 to both sides. So 10 equals x sub 2. So the coordinate B is the ordered pair 10, negative 1. I'm going to plot these. These should fit on here. So A is the point negative 2, 1, 2, 3. The midpoint is the ordered pair 4, 1. And B is the ordered pair 10, negative 1. So I know that I know again that doesn't fit, but something like this. Remember that the midpoint is just cutting that segment into 2 congruent pieces. Okay? All right, now let's talk about distance formula. Distance. Well, first of all, the distance formula was derived from Pythagorean theorem. Hopefully you learned that yesterday when you watched your little Pythagorean theorem video. But the distance formula, if you, I'm going to kind of step away for a second and I'm going to do what you learned about Pythagorean theorem. This is 3 and this is 4. And I know that this is 5 units long because this is a 3, 4, 5 Pythagorean triple. But this is the ordered pair 3, 0. And this is the ordered pair negative 4, 0. I lied. This is the ordered pair 0, 3. So the distance formula is derived from, if you think about Pythagorean theorem, you would take the number 4 and square it. And you would take the distance of this side and square it. And then you would find the square root of that, right? And that would give you 5. Well, since we have negative numbers, whenever we have negative numbers and we try to find distance, we're trying to find the change in x, right? I have to find the difference between the two x coordinates, which gives me that number 4, and the change in the y. So let's talk about how we find the change. The change, x1 minus x2, that gives me the change in x, but I can't have any negatives. So if I square it, then I get rid of the negatives. Plus the change in my y, y1 minus y2. Again, I don't want any negatives, so I have to square it. And then just like with the Pythagorean theorem, I'm going to take the square root of all of that. So this is the distance formula. So the distance formula, believe it or not, came from Pythagoras, which I think is super cool. Super, super, super cool. So we're going to use the distance formula to figure out the distance between 2 points. So sometimes it helps to visualize the two ordered pairs. So this is the ordered pair 3, 7. And this is the ordered pair negative 1, 4. All right. So if I were to turn this into a right triangle, this is 3 units and this is 4 units. So I already know from Pythagorean theorem that this needs to be 5, but I'm not using Pythagorean theorem to prove this. I have to use the distance formula. So the distance formula is the difference between my x coordinates, 3 minus negative 1, the quantity squared, plus the difference between my y coordinates, 7 minus 3. All right, so let's check that. 3 plus 1 is 4. I have to square that. And 7, 1, 2, 3, 4, 5, 6, 7, and negative 1, 1, 2, 3, 4. Interesting. 1, 2, 3, 4. 1, 2, 3. I'm doing something wrong here. 3. Oh, I see what it is. This is a 4, not a 3. It's like, that's not going to work out. The y coordinate, 7 minus 4. Sorry about that. Okay, so 7 minus 4 is 3, the quantity squared. So let's see. 4 squared is 16, plus 3 squared is 9. But 16 plus 9 is 25, and the square root of 25 is 5, which is exactly what we got using Pythagorean theorem. Okay, let's do this again. So I have the ordered pair 5, 2, and the ordered pair 3, 10. So I'm trying to figure out the distance between the two of them, which is the hypotenuse, okay? So let's see. The distance formula is the square root of the distance between, or the difference between, my x coordinates, 5 minus 3, the quantity squared, plus the difference between my y coordinates, 2 minus 10. Remember, just like with slope, if this is my first x coordinate, this has to be my first y coordinate. If this is my second x coordinate, this has to be my second y coordinate. That is important, okay? So let's see, the distance equals, well, 5 minus 3 is 2. So I have 2 squared plus 2 minus 10 is negative 8. So I have negative 8 squared. This is an example of, having a negative for distance. That's why we square it. So 2 squared is 4, and negative 8 squared is negative 8 times negative 8, or positive 64. So the square root of 68. Now, 68 is not a perfect square. So in my calculator, I have to find the square root of 68. So the square root of 68, and we're going to round our answers to 2 decimal places. So the distance is about 8.246. I want 2 decimal places. So this is the second decimal. This number tells me to round it up or keep it the same. Well, hopefully you notice that this number tells me to round it up. So my distance is about 8.25. Now, I know the directions in the note say round to the nearest tenth, but I had already pulled that up in my calculator and I wanted to kind of refresh your rounding brain. All right, we're going to find the missing coordinates. So I know the distance between the 2 points is the square root of 244. So the square root of 244, which is my distance, this is D, equals, well, let's see, the difference between the 2 x coordinates, 8 minus r squared, plus the difference between the 2 y coordinates, negative 5 minus 7. All right, so 244 underneath the radical equals, let's see, well, I have 8 minus r squared plus negative 5 and negative 7, the quantity squared, well, that's negative 12. And when I square that, something unique happens. So the first thing I want to do is remind you that the only way to get rid of a radical, the only way to get rid of a square root is to square it. That's how you cancel it out. But remember with equations, whatever you do on one side, you have to do on the other. So I really have this very basic equation that says 244 equals 8 minus r, the quantity squared, plus 144, okay? Because negative 12 squared is 144. I am going to subtract 144 from both sides. So 244 minus 144 is 100. 100 equals the quantity of 8 minus r squared. Okay, the only way that I can get rid of that square, remember I said in yesterday's video, the only way to unsquare something is to take the square root of it. But whatever you do on one side, you have to do to the other. I'm trying to unsquare this. Well, I know that the square root of 100 is 10. And I know that the square root of 8 minus r, the quantity squared, is just 8 minus r. Okay, so now I'm going to subtract 8 from both sides. 10 minus 8 is 2. So 2 equals negative r, which means that r equals negative 2. So we're going to check this. We're just going to put this in to the distance formula and check it. So the distance between my x values, 8 minus negative 2 becomes 8 plus 2, the quantity squared, plus the distance between my y values, 5 minus negative 5 minus 7, the quantity squared. Well, hopefully you can already see that 8 plus 2 is 10, squared is 100, and negative 5 minus 7 is negative 12. And when I square that, I get 100 plus 144, which does in fact equal the square root of 244. This is some new stuff here, squaring and unsquaring. All right, So we're going to do some applications of midpoint and distance formula. So we're finding the midpoint and the distance between the given points. And we have to use the midpoint and the distance formula. So remember that this came from a right triangle, right? That's where the distance formula came from. So I, first of all, need to find out what my points are. So my first ordered pair is the ordered pair 2, -3. And my second ordered pair is the ordered pair 5, 3. All right, so for the midpoint, remember, the midpoint is the x-coordinates, 2 plus 5 divided by 2, and the y-coordinates, -3 plus 3 divided by 2. So that means that the midpoint is 7/2 and 0. Well, I'm just going to go to where 7/2 and 0 lives, and I'm going to plot that. All right, now let's find the distance. Well, the distance is the square root of the difference between the x-coordinates, 2 minus 5, the quantity squared, plus -3 minus 3 squared. So 2 minus 5, that's -3. -3 squared plus -3 and -3 is -6 squared. So let's see, -3 squared is 9, and -6 squared is 36. 9 plus 36 is 45. So the distance is about the square root of 45. And the square root of 45 is 6.71. Again, that's if I round to the nearest hundredth. Okay. All right. Randy plotted a triangular patio on a landscape plan for a client. What is the length of fencing that he will need along the patio edge that borders the property line? Round your answer to the nearest tenth. So we are trying to find the length of fence needed that borders the patio edge on the property line. And that's this right here. Okay. So my two ordered pairs are the ordered pair 6 and 8 and 5 and 1. So the distance formula, the difference between the x-coordinates squared plus the difference between the y-coordinates squared. Well, 6 minus 5 is 1, and 1 squared plus 8 minus 1 is 7 squared. Well, 1 squared is 1, and 7 squared is 49. So the distance is the square root of 50. And the square root of 50 is about, rounded to the nearest tenth, 7.1 units. All right. On a map of coordinate grids, the old city is located at the point -2, 2, and the new city is located at the point 5, 6. Boring Town is the midpoint, and we need to find the approximate distance from Old City to Boring Town. So first, we need to find the midpoint, which is Boring Town. Then we are going to find the distance between Old City and Boring Town. So let's find the midpoint first. So the midpoint, well, -2 plus 5 over 2 and 2 plus 6 over 2. Well, that reduces to 3/2 and 4. So this is Boring Town's coordinate. Now let's find the distance formula. So the distance formula, Old City negative 2 minus 3 halves, the quantity squared, plus 2 minus 4, the quantity squared. All right, 2 minus 3 halves, negative 2 minus 3 halves is the same thing as negative 3.5 squared plus 2 minus 4 is negative 2, the quantity squared. So at this point, I'm just going to put this all in a calculator. So the square root of 3.5, the quantity squared, so parentheses squared, plus, and it's actually negative, I put a negative 3.5, sorry, plus negative 2 squared equals, oh my goodness, let me try it again. So the square root of parenthesis negative 3.5 quantity squared plus negative 2 the quantity squared, close my square root, is about, I just did the whole thing, so I'm going to get rid of this. It's about 4.03 miles. Okay. All right. The Martinez family is planning a trip from their home to Fort Lauderdale, Tallahassee. In Fort Lauderdale to Tallahassee. So we're starting right here, and we're planning on going here. They plan to stop overnight at a location about halfway between. What are the coordinates of a point halfway between Tallahassee and Fort Lauderdale? Well, Tallahassee is the point negative 5, 1, 2, 3, 4, 5, 6, 7. So Tallahassee is at negative 5, 7. And Fort Lauderdale is at positive 5, negative 5. So we need to find the midpoint. So negative 5 plus 5 over 2 and 7 minus 5 over 2, because that's plus a negative. Well, that's the ordered pair 0, 1. So the midpoint, the halfway point between these two cities, is right here at the ordered pair 0, 1. It asks which city is closest to the point 0, 1. So my choices are Orlando, Land of Lakes, St. Petersburg, Tampa, or Plant City. And it looks like Plant City is the closest. So that is where they're going to stay. All right. What is the perimeter of triangle ABC? Well, I'm going to label my points A, B, and C. So A is the ordered pair 1, 5. B has coordinates negative 4, negative 5. We're going to say that's at negative 5. 1, 2, 3, 4, 5, 1, 2, 3, 4. So that's negative 5, 4. And C has coordinates negative 3, negative 2. So we have to find the perimeter. So that means that I have to find the distance from A to B. I have to find the distance of B to C. And I have to find the distance of A to C. So let's start with the distance of A to B. So 1 minus a negative becomes 1 plus 5, the quantity squared, and 5 minus 4, the quantity squared. So I'm going to do some simplifying kind of in my head. 1 plus 5 is 6, squared is 36. 5 minus 4 is 1, squared is 1. So this is the square root of 37. The distance from B to C, so the x coordinates, negative 5 minus a negative 3 becomes plus 3, the quantity squared, plus 4 minus a negative 2. So again, we're going to do some simplifying. Negative 5 and 3 is 2, squared is 4. And 4 plus 2 is 6, squared is 36. So this has a square root of 40. And then the distance from A to C, well, the difference between the A coordinates, negative 3 minus 1, the quantity squared, plus negative 2 minus 5, the quantity squared. When I simplify that, negative 3 and negative 1 equal negative 4. Negative 4 squared is 16. Negative 2 and negative 5 is negative 7. And negative 7 squared is 49. So this is the square root of 65. So it says to give a radical answer, but that would just be adding all these together. So I would say that it's the square root of 37 plus the square root of 40 plus the square root of 65. You can't like actually combine radicals. They're like different variables. Unless the radical, the number under the radical is the same, you can't combine them. So this is almost like saying x plus y plus z. But we can approximate their value. So I have the square root of 37 plus the square root of 40 plus the square root of 65. And that is about 20.47 units. Okay. So your homework for today, you are completing pages 13, 14, 15, and 16. Now, I've already posted my answers, but that's all I did. I only posted answers. Okay. So remember, if you do not show your work, you will not receive credit. Okay. Show your work.